Function f of x equals x cubed is transformed to get function g. G of x equals negative 3 times x plus 2 quantity cubed. Which statements are true about function g? So conceivably there's going to be more than one answer. And I'm going to flip over here to Desmos to try to answer here. And the first two possibilities are, we'll turn it on. So here's our function. And I believe that the first question said that the first answer said that the infinity, which is true. Because one end of the graph goes upward and the other goes downward, our range is going to cover everything from the lowest point to the very highest point. The domain, I need to flip back here for a second. The domain is negative 2 to infinity, which is not true. So I do think that that is true. But the domain in this particular graph, a cubed graph, a cubic function, is also all real numbers, which is negative infinity to positive infinity. We go from the far left value for domain to the far right of the domain. We don't just start at negative 2. We've got values that are to the left of negative 2. So if we go back to our question again, the y-intercept is 0, negative 2. Well, let's look at our picture. We can't even see our y-intercept on here, so that's not an answer. As x approaches negative infinity, g of x, which is also known as y, approaches positive infinity. So sorry about my dogs barking in the background, but as x approaches negative infinity, so we're going in this direction, what's happening to our graph? Upward. So as x approaches negative infinity, g of x, or y, is approaching positive infinity, I believe is what that says. Yes. The next one, the x-intercept is negative 2, 0. Well, it's just a matter of going back to the graph. And sure enough, this point right here is negative 2, 0. So yes, that is true. As x approaches infinity, g of x, also known as y, approaches infinity. Well, that means we're going this direction on the graph. But what happens when we go downward? So that last statement is not true. So there are our answers for this particular problem.